So if you go to to Blackboard, and course information is where all the interesting stuff is. Down below here is where the lecture recordings are going to appear once there are some. This is my contact information. Usually email is the best way to get in touch with me. Or just come to this classroom. This is where I spend most of my life. The syllabus we'll look at in a second. Instructor Schedule is here if you wanted to look at that. If you needed to come talk to me and wondered when I'm free or when I have open time. You can see that after this class every day, I have at least a half an hour open. So after this class, each time you guys have me, if you have any questions, I should be able to hang around. Otherwise, we got time in class to do homework and stuff as well. Mornings, Monday, and then Wednesday, Thursday, Friday, I've got that 10:30 to 11:30 hour open as well. Okay, syllabus. I already showed you my contact info. You guys are here, so you know when and where class is. Before I get too far, I should pull up the class roster and make sure I have everybody I'm supposed to have in here too. There are two of you in here that didn't have class last time around, so I should tell you. This is the description of this class. This is basic geometry, ratio and proportion, solid figures, areas, volumes, and then trigonometry. So trigonometry, right triangle trig, oblique triangle trig, trig applied to surfaces in construction, areas, volumes, and all that wonderful stuff. A more detailed list is this list down here. If you're looking through that list and you're thinking to yourself, that looks pretty easy, I know all that stuff. There is a test out process for the class. I will warn you, in 17 years here, I have had 30-some people attempt the test out for this class. I've never had anybody pass it. So it's not the difficult, it's just the mixture of topics. Unless you know exactly what to study for, it's a tough test. Okay, materials for those of you that weren't, those of you that are in your last semester, it's the same book. Those of you that are new, it looks like you both have it, so we're good there. Calculators, it's highly recommended you have a scientific calculator. I don't stop you from using your cell phone, but those usually don't work that well. Grading, same as last semester for those of you that are continuing. 80% of your grade is on tests and quizzes. There will be 4 unit tests in here. Oops. 4 unit tests, each of those is 100 points each. Quizzes are unannounced, and there will be one probably every 3 to 4 hours of class, sometimes 2. Those are anywhere from 8 to 20, 25 points, depending on how big they are. Homework, then, I will never collect your homework and grade it. The homework is for you guys to practice and learn. Because I guess this semester I'm down to only like 90-some students, but it's just, there's no way I could possibly collect and grade everybody's homework. So that 20% of homework and participation just becomes show up for class and show me that you're working. Really, to me, like I said, the homework to me is a learning experience for you to prep and know the stuff so you're comfortable taking a quiz. Standard WITC grading scale. Withdrawals or drops. The biggest thing I say about that is if you are considering dropping a course or withdrawing from school, don't just do it. Don't just disappear for one. Make sure that you do go through the process of dropping if you're not going to finish a class. But make sure you talk to someone. There's always consequences, whether it's financial aid or other things. So make sure you talk to someone before you drop a class. And then, of course, the standard stuff. Don't cheat. Don't do stuff you know you're not supposed to. Don't use school equipment for anything bad. All that good stuff. If you have any needs, let me know. We'll figure out how to make this class work for you. And then again, as I mentioned, the class is recorded. This class is posted on YouTube. So it's not on a secure server, so it is out there for the public to see. So don't say anything in class that you don't want put out there for everybody. For those of you that don't know, what gets recorded is what's up on the screen with sound over the top of it. So your face will never be on screen, will never be recorded, but your voice might be. So if you don't want your voice recorded, let me know, and I can like pause the recording or whatever while you ask a question or say what you need to say or whatever. And those are the 3 main units for the class. I did say 4 units. There's some small stuff at the end that we add on depending on how much time we have for our 4th unit. Any questions on procedures? Okay, I should do attendance quick. We got Tate, we got Richard, Jake, and Ben, right? Just the 4 of you. Okay. So, what I want to do, for 2 of you that were here last semester and for you guys that are coming in new, I want to give you a chance to review a little bit. One of our biggest topics from last semester. Most important topics, really. Area, volume, and surface area. Now, just so you know, I know even last semester I let you guys do a lot of group work. This semester we do a lot of group work just because of the nature of the topics. There are some very long processes. I know you guys thought some of them last semester were kind of long. They do get longer. Multi-step. Start throwing trig into areas and volumes where you have to use trig to find missing dimensions before you can calculate the volumes. It can be a lot of fun. No sarcasm there, I swear. It's a lot of fun. So just a little review. Some of our more difficult problems. How would we find the area of this parallelogram? I'll mark it like that so you know the opposite sides are equal so you know it's a parallelogram. What would we do? Well, when we go for areas, can I multiply, let me put it this way, can I multiply 24 feet by 17 feet? No. When I'm looking at areas, I have to have 2 dimensions that are not equal, but perpendicular. They have to be right angles to each other. So if I'm going to use the 24, I need this dimension here. That would be at a right angle. Can I find that dimension from the information I have? Yes, I can. How? Pythagorean theorem. There you go. A squared plus b squared equals c squared. This is a right triangle here. These are the 2 legs, so I'm going to label them A and B. This is the hypotenuse. A squared plus b squared equals c squared. A is 8, so that's 8 squared plus b squared equals 17 squared. 8 squared is 64 plus b squared equals 17 squared is 189. Everybody's going to stop me? 289. Now what do we do? Subtract 64 from both sides. Trying to get b by itself. So now we got b squared equals 225. And then square root. So square root of b squared is just b. Square root of 225 is 15. So it's 15 feet. So my area is 24 feet times 15 feet, otherwise known as 360 square feet. Look familiar? Okay, Jake and Tate, I'm going to put you guys to the test here a bit. So this is a 60-degree sector, 12-foot radius. I want to find the area of the segment. Now, I will give you a hint. Step one is to find the area of the sector. Remember, the sector is that whole pie wedge. Can you give me just a brief idea how you find the area of the sector? Find the area of the complete circle, and then you multiply by the central angle over 360, right? In this case, it's 60 degrees. Step two, area of the triangle. And the triangle is this right here. Now, we don't have a right angle there, so how do we find the area of the triangle? Hero's formula. Step three, subtract. I'm going to have the four of you work together quick. See if you can remember how to do that. The two of you can remember, or if the two of you know. Okay? See what you come up. So let's see how you're doing here. Step one is to find the area of that sector. Did you find the area of the whole circle? Yes, no. Area of the whole circle is pi times radius squared, so 12 squared. So we're just going to use 3.14, but for now, times 12 squared. 452.16. Those are in feet, so this is in square feet, by the way. Area of the sector. That was the circle. This is going to be the sector. What do I do to find the area of the sector? The 452.16 is the area of the circle. Times what? over 360. The central angle over 360. Which is going to give us, what, 75.3735 about? 36. Correct? Close enough? Did you guys make it that far? You're getting close to it? How about the area of the triangle then? Did you find that? That's what you're working on? So, that is an equilateral triangle, 12, 12, 12. The reason we know, 60-degree central angle. So this also has to be 12 feet over here. So the perimeter, 12 plus 12 plus 12, or 36 feet. For Hero's formula, you use the semi-perimeter, which is the perimeter over 2, for 18 feet. If your sides are labeled sides A, B, and C, well, they're all 12, so it really don't matter which. The area is the square root of the semi-perimeter, 18, times the semi-perimeter minus side A, times the semi-perimeter minus side B, times the semi-perimeter minus side C. .35 is the area of that triangle. Those lengths were in feet, so that is feet squared. So the area of the segment is the area of the sector, 75.36. Minus the area of the triangle, 62.35 square feet, 13.01 square feet. What do you think? Still better than a sharp stick in the eye? Yeah. No. Bracing for impact? Pretend that looks like a box. I did a pretty sloppy job of drawing it there, but it'll work. Let's say this is 12 inches, 8 inches, and 10 inches. I want to find volume, and I want to find surface area. We're going to find volume first. Remember, volume is defined to be the area of a base times the height. The base is the shape that creates the whole object. Now, on a box, you can pick any side. Any side can be used as the base. Because I take any side and I could actually run it through the whole object. So in a box, we choose the bottom to be the base. So what is the area of that base? How do I find it? 12 inches times 8 inches. Or 96 square inches. So my volume, the area of that base, what's the height? 10. The base always has another base on the opposite side in most of our objects. The height is the distance between bases. That's 10 inches. This is 960 inches cubed. Surface area. Surface area is defined to be the area of the bases plus the lateral area. So the area of the bases here, we've got 96 and 96. Still got to find the lateral area. Lateral area, if you recall, is found by taking the perimeter of the base. The lateral area, the lateral sides are the sides that connect the two bases. So that's this rectangle up front here, the one on this end, the one on the back, and the one on this end. If I roll them all out, fold them all out and make one big rectangle, and the size of that rectangle, well, the length of the rectangle is just the perimeter around the base. That's the perimeter of the base. And the height of that rectangle is still just the height of the box, the height of the figure. So the perimeter of the base here, come on, is 12 plus 8 plus 12 plus 8, right? Otherwise known as 40 inches. So that means my lateral area is 40-inch perimeter times that height of 10 inches, or 400 square inches. That adds up to 592 inches squared is my surface area. What do you guys think? Okay. What I want you guys to do, I want you to look at in the big book, page 585 through 589, 1 through 49, the odds. It's a review of areas of rectangles, triangles, parallelograms. Page 601, 603, 1 through 31, the odds. That's area of circles. Page 615 through 616, 1 through 15, the odds. That's the area of boxes. So for right now, that's going to be your first set of homework. We'll come back at about 1:20, 1:30 here, and we'll lecture a little bit more. We'll talk a little bit more.